This problem has three different sets of parentheses, and so this is another problem that's going to be done by using the distributive property. So for this, we need to multiply the 3 by both things inside here, and we'll also distribute the -2 and distribute the 5. So let's do that first. We're going to get 3x minus 24 we get here. 3x minus 24. Then we have minus 2 times 10 is minus 20. And negative is positive 2x. We have a greater than, and we have 5x minus 5. So that step, we distributed everything and gotten rid of the parentheses. But now it's time to add like terms together. So I've got a 3x and a 2x. That's going to be a 5x. Then we have minus 44 greater than 5x minus 5. All right, so we've got that. Now we need to get all the x's on one side of the equation. So I'll just subtract the 5x from both sides. Now what happens is we get something interesting that happens here. The x's cancel out, and we end up with this statement here. We end up with negative 44 minus 5. So then you want to think, is that a true statement? And the answer is no, it's not a true statement, because the farther negative you go, the smaller you get. So negative 44 can't be larger than negative 5. So even if I were to divide both sides by a negative, then the sign would flip and I would just get 44. I would end up getting, so if I divided both sides by -1 here, I would get 44. Whenever you divide an inequality by that, you have to flip the sign, and then you would get that. Then you would get 44 is less than 5. That's still a false statement there. So because this is a false statement, what you would actually put here is this is a situation where it's going to be no solution. So that means that no x that you put in here will ever make this equation correct. So that's why we have no solution. Now, if you do the same problem, and let's say we did the whole problem and we got something like, maybe we'll get something like this, like 1 is less than 7 or something like that. Just for example, that's different from this problem that we had here. Now, if you get a situation like that, then what you would enter for this one is you would enter infinite solutions, because that's a statement that would always be true. That means that no matter what value you put in here for x, it would always be true. So in that case, you get infinite solutions. So in this case, we got a false statement. When we went through everything, the x's canceled out. We got a false statement. That's why we put no solution here, because the statement we got as a result is false. Okay, but if you get a true statement, that means then you'd have to answer infinite solutions. And of course, that's the same case where if all the x's cancel out and the statement you end up with in the end is true always, then you'd have infinite solutions.